This is the Chapter 6A assignment video, and the first question says, in a recent poll of an upcoming election, candidate A has a 46% percentage of the votes, and candidate B has 54% of the votes, with a margin of error of plus or minus 3.5%. Construct a 95% confidence interval for each candidate. So the way we do that, the formula for that is we just need a lower and upper limit. So we know that the poll showed that 46% would vote for candidate A. However, we know that the poll has a margin of error associated with it. So we've got to get the lowest that it might be, the lowest percentage that might vote for candidate A. So we've got to factor in the margin of error. The formula, let's write out the formula first, is that you take your p-hat, and that's your best point estimate, and you subtract your margin of error. And then to get your upper limit, you take your p-hat, which is your best point estimate, and then add on the margin of error. So specifically, our p-hat, the best point estimate that we have, is that 46%. We're going to subtract off 3.5% to get our lower limit. The upper limit is the 46% plus a margin of error. So to get our actual confidence interval, the lower limit is 46 minus 3.5%, which is 42.5%. The upper limit is 46 plus 3.5, which is 49.5. So this is our confidence interval, and this means that we are 95% confident that the true proportion of voters that would vote for candidate A is somewhere between 42.5% and 49.5%. Now notice, for this particular problem, I have written this as a percentage, but sometimes we will write these as decimals. Just kind of depends on what the problem's asking for. So just pay attention to that when you're doing your homework. Let's look at the one we would build for candidate B. So again, our general formula is whatever the p-hat is, that's our best point estimate, minus the margin of error. Our upper limit is our p-hat plus the margin of error. So specifically, what we're doing is we're taking, this time for candidate B, that's the 54%. So we're taking 54% and subtracting the margin of error of 3.5%. And we're taking the 54% and adding on the 3.5% margin of error. So working that out, we get 54 minus 3.5 is 50.5. And then 54 plus 3.5 is 57.5. So this is our 95% confidence interval. And what this means is we're 95% confident that the true percentage of voters that would vote for candidate B is somewhere between 50.5% and 57.5%. So the question asks, can we safely say that candidate B will win the election? Well, we can be 95% sure that he will, because the lowest limit would be a majority vote. That's a little more, just barely, but a little more than the majority vote, a little more than 50%. So we would say yes. We can't always do that, but in this case, our lower limit is above 50%. So he would get the majority of the vote if we look at the confidence interval here. So we would say yes, it appears that candidate B will get the majority, which is more than 50% of the vote. The next problem asks us, it's telling us that in a recent survey, slide that over there, excuse me. It says in a recent survey, we are 95% confident that the population percentage of all adults believe that UFOs is between 16.25% and 22.75%. So here we're given the confidence interval already. We already know what it is. It's a 95% confidence interval. And our lower limit is 16.25%. The upper limit is 22.75%. And I'm leaving these as percentages, not decimals at this point. But we're trying to find out, okay, well, this is our confidence interval. We're going to kind of work backwards to figure out, well, what was our p-hat? What was our best point estimate that we were working with to get this confidence interval? In other words, we had a p-hat. We subtracted a margin of error to get this value. And then we also had a p-hat, a best point estimate, and we added on the margin of error to get this value, the 22.75. So the math of this, the way we can figure out, what was our p-hat? The way to do that is we can use this formula here, but we're finding the middle value. But how you would do that is you take the 22.75 plus the 16.25 and dividing that in half, dividing that by 2, and that gives us the middle value, the middle percentage there in the middle of that confidence interval, which is 19.5%. Now we got to figure out, okay, what's E? So we took our p-hat and we added on E to get this. Then we took our p-hat and subtracted E to get this lower limit. So what did we do? What did we add to this to get here? And what do we subtract from p-hat to get here? That's what E is. That is our margin of error. The formula, the easiest way to compute that is to take the upper limit minus the lower limit and divide by 2. So here we are adding and here we're subtracting and then dividing by 2. So that gives us E. That is actually it's 3.5%. That's our margin of error. Now sometimes we write it like this, plus or minus 3.5%, because we take this value and subtract 3.5 to get our lower. And then we take our p-hat and we add 3.5% to get our upper limit. So there we go. We worked backwards from a confidence interval to find p-hat and E. And the next question says, in March 2010 poll of 1,500 American adults, 1,015 described themselves as totally happy. This category included both very happy or somewhat happy responses. Use StatCrunch to construct a 95% confidence interval for the proportion of American adults who describe themselves as totally happy. So I'm going to underline the things that are important. We're going to build a 95% confidence interval. Sometimes this might be a 90% confidence interval. Sometimes it might be a 98% confidence interval. But this is the most common one that's used, but not always. So that's important. We also need to know this, that we surveyed 1,500 adults, and we need to know that of those 1,500, there are 1,015 that describe themselves as totally happy. So let's get down what we have here from the problem. What is our best point estimate? Okay, so our best point estimate is just, what did the survey show? As far as what percent of people are totally happy or say that they're totally happy. So we would say that our p-hat, best point estimate, is just that proportion or that percentage of adults that describe themselves as totally happy. So that's the 1,015 adults out of the total of 1,500. So 1,015 divided by 1,500 is 0.6767. Now I'm leaving this as a decimal this time, not a percentage. So that's our p-hat. Now we are going to figure out what the margin of error is. So what I'm going to do, just like in the problem before when we computed the margin of error by using the upper and the lower limits, I'm going to do the same thing here, but I'm going to use StatCrunch to find my upper and lower limit. And then we can use those numbers to figure out what E is, what the margin of error is. So I'm going to show you how we do that in StatCrunch. X off of this. X off of this. So we're working with proportions or percentages. This is a proportion here, percentage. So that's how I know that we go to Stat And since it's a proportion, we go to proportion stats. We're dealing with a percentage of adults that describe themselves as totally happy. So one sample, stat, proportion stats. One sample with summary. Number of successes. Well, that's the 1,015 adults that said they were totally happy. Number of observations, that's the 1,500 adults that we surveyed. We click this button here to have StatCrunch build our confidence interval for us so we can get our upper and lower limits. Our confidence level is 0.95. We hit compute. So here they are, and these are in decimal form. So this is our lower limit, and this is our upper limit. So I'm just going to use the formula that we have to compute the margin of error when we have an upper and a lower limit. So E is equal to, we take our upper limit, and I'm going to round to 4 decimal places here, 0.7003, minus the lower limit, which is 0.6530, rounding to 4 decimal places. I'm dividing that by 2. So when I do that, I get 0.0237 as a decimal. If we're leaving it as a percentage, that would be 2.37%. Either way, but I'm going to work with the decimal this time. So now it says to construct the confidence interval. So what we could do is we could do this one of 2 ways. Actually, we already have our confidence interval because we have our upper and lower limit. We could kind of check ourselves if we wanted to and do it this way. We could take our p hat and subtract a margin of error, and that should give us our lower limit. And then we can take our p hat and add the margin of error, and that should give us our upper limit. But we can just simply write it out like this. Whoops. We could say our 95% confidence interval, the lower limit is 0.6530, came straight from StatCrunch, and the upper is 0.7003. Or sometimes we may write it as a percentage, which would be 65.3% is the lower, and 70.03% is the upper limit. So we're a little picky about how we word our statements when we build these confidence intervals. So I'm going to write it out word for word what this means. We're going to say, we took this survey, we got this information, 67 roughly percent of people said they were totally happy, but we're really just 95% confident about that, and we need to give ourselves some wiggle room. So we're 95% confident that it's really somewhere between 65% and 70% of adults would say they're totally happy based on this survey. So we use the survey, we use this p hat that we got to build a confidence interval about the entire population of adults. And we would say that we're 95% confident that the true population percentage of adults that are totally happy is somewhere between 65% and 70%. So let's write it this way. Let's say we are 95% confident that the true population proportion or percentage of adults that describe themselves as totally happy is between 65.3% and 70.03%. This question here says, can we safely say that more than half of American adults describe themselves as totally happy? And yes, we can, because we're definitely more than 50%. We're somewhere between 65 and 70%. So yes, we can say that more than half of adults are happy. Smiley face. All right, last problem. As a newly hired manager of a company that provides cell phone service, You want to determine the percentage of adults in your state who live in a household with cell phones with no landlines. How many adults must you survey? So assume that you want to be 98% confident that the sample percentage is within 3 percentage points of the true population proportion. Use StatCrunch to calculate the following sample size. So we want to figure out, what percent of the population live in households with cell phones and no landlines. And we've got to ask some people. We've got to do a survey, and we're trying to figure out, well, how many do we really need to ask? It kind of depends on how confident do we want to be about it and how accurate do we want to be. So we want to be 98% confident, and we want to be, our margin of error needs to be within 3 percentage points. So our margin of error is 3%. So what do we do? How many people do we need to ask is what this question is talking about. Now, this part A is different from part B. Part A says, assume that nothing is known about the percentage of adults who live in a household with cell phones and no landlines. Okay, so it's like we know nothing about this. This part of the question is going to say, well, we know a little something about this. There was another survey. It says, assume that a recent survey suggests that about 8% of adults live in a household with cell phones and no landlines. So 2 different ways of thinking about this. Here we don't know anything. So we're probably going to have to ask more people because we have no starting point. We know nothing about this. Here we're saying, well, there's this other survey, and it's showing that about 8% live in a house with a cell phone and no landline. So it's a couple of different ways we do this. Now, this is what's important here. This, we need to know, this is our confidence level. This is important. We're going to put all this in StatCrunch. This 3 percentage points is our margin of error. Now, when we go to StatCrunch, we enter this in at a place where it says width, and that is simply the width of our confidence interval. So the width of your confidence interval is 2 times the margin of error because we have the lower and the upper. So our width is going to be 2 times 0.03, 3%, or 0.06. That's going to be, we need to enter this part in StatCrunch when we're letting it know how accurate we want to be. The other thing that we are going to have to tell StatCrunch is this, that we know nothing about the percentage of adults. So in StatCrunch, there's a place where we enter something called the target proportion. So in this example, we don't have a target proportion. We don't know anything. So in this case, when you don't know anything, we just start at 50%. We just say 50% there. So let's look at this in StatCrunch and see how this is going to look. Remember, I do have the steps for StatCrunch in your notes, in this chapter in your notes of what to click on. So here we go. We're going to go to Stats, and this is about a proportion stats. We're only dealing with one sample. Now this is where we go all the way down here to width/sample size. This is how StatCrunch will find our sample size for us. And here is where we input everything that we know. I need to change this. We want to be 98% confident. Our target proportion is going to stay at 0.5. We do not have any prior information about this, so we're just going to put it at 50% or 0.5. And the width of our confidence interval that we want to build is going to be 2 times the 3%, 2 times 0.03. So it's going to be 0.06 is the width. So we enter these 3 things, and when we hit compute, it'll give us the sample size. So we don't know the sample size. That's what we're trying to find out. So when I hit compute, let's see, I think I left something off here. Let me go back. This is 0.06, and so when you hit compute, you get your sample size. So we need to ask, our sample needs to be from 1,504 people. So N always stands for sample size. Our sample size is 1,504. So what this means is, if we want to be 98% confident that the sample percentage that we're going to get from our survey is going to be within 3 percentage points of the true proportion, we're going to have to ask 1,504 people. So let's write this out. To be 98% confident that the sample proportion that we take, that the sample proportion of adults that have a cell phone with no landline is within 3 percentage points of the true population proportion we need to survey 1,504 households. Now, how does this change when we have this target proportion, where we have this prior survey that suggests that 8% live in a house with cell phones and no landlines? So what that looks like over here in StatCrunch is we leave everything else the same except this. I'm going to go ahead and clear out the sample size here. I'm going to clear this out. But this stays 98. Our target proportion now changes to 0.08. And our width stays the same. That was our margin of error was 3%. So 2 times the margin of error is 0.06. I don't know why it keeps doing that. And hit compute. So there we go. So we need to sample 443 households if we want to be 98% confident. If we already have that prior study that suggests that 8% of adults live in a house with a cell phone and no landline. So 443. So our concluding statement would be the same as this one. However, we would just change this to 443 households. And we would also add to that statement somewhere that we are using a prior study that suggested 8% of adults live in a household with cell phones and no landlines. So we would say to be 98% confident that the sample proportion that we take, the sample proportion is within 3 percentage points of the true population proportion, the true population proportion we need to survey 443 households using the prior target proportion of 8%.